So we are going to study. So we are going to have our. So we are going to study what scattering in that sense. So we will have a जो हमारी इसकी general formula of scattering, general general formula of scattering. So as you know, you might have studied Rutherford scattering, but we are doing the same scattering here also. So the only thing is that the scattering here we are interested in how quantum mechanics takes into consideration. So classical scattering you try to understand. You can also have Rutherford's understanding of scattering formula. Also you can have a classical understanding how we study classical mechanics, cross section, collisions, and in a given frame. So we here, if we want to say, if we have to if we want to investigate into general formula, so हम क्या करेंगे काम? So we'll examine the properties of phase delta L, then for large values of L, for large values of L. L is basically once we studied yesterday, if you remember, हमने Schrödinger equation का जो solution है ऐसे r square dr by dr k square minus L into L plus 1 by r square minus 2m by h square u r. Psi was basically given upon A L P L cos theta and R A L R. So you taking these things into consideration, this is the solution. So we have to see uh, how we can just arrive at general consideration of scattering. So what we have to do is, for example, if we see in that sense, if you remember, once we classical mechanics study things, motion, so determine the phase of delta L for large values of L, for large values of L. So we'll take the fact that motion is quasi-classical at a large L, and the phase of wave function is given by integral. जो हमारे पास classically once we study integral, so form ऐसे आता है. We are going to take for large L as if इसकी motion goes from R1 to R, it's satisfied by this integral. L plus half square minus twice m u r by x square dr plus 1 by 4 pi. Now for r greater than r, for classical regions which are accessible to classical regions, so ये हमारे पास the integral will turn out to be r naught will turn out to be, for classical regions, it will turn out to be k square minus L plus r square by r square dr plus 1 अब ये है कि we can let delta L and let it, or for example, a particle may be coming from infinity or it's going to infinity. जिस तरह हमारे पास रदरफोर्ड स्ट्राइक है, particle will come from infinity से आ रहा है and it will come back in that sense. So a particle may come from infinity or it can go to infinity in both cases. You can see how we are going to see the things such that we obtain by differentiating the quantity delta L. So for large values of R, for large values of L, the value of also becomes large. And for small values, throughout the range of integration is for small values. So if you say if it's if the integral goes from 0 to infinity or not to some infinity. So if the value of integral goes from some finite value to infinite value, तो ये integral आएगा denominator में, it will come in the denominator and it will have this form. If you take it from the right hand side and simplify it, delta L, if it goes from R naught to infinity, so if it's m upon m dr, so this will come out to be in the denominator h square root of k square minus L plus half square R square. Now question is when can this magnitude of this integral be? It can be convergent or it can be divergent. Depends. Depends किस पर depend करेगी? Depends. It depends upon the fact that, for example, if the integral is convergent, then delta L is proportional to m mu naught or naught divided by k square. So if the integral is convergent, this means this is large, this is small, this is large, this can be large, and in the denominator will be large, and this will come closer to this. So you can say, so if it's small, it will be large, so it will be negligible. So you can this integral can be written like this for this thing. So the order of magnitude R naught is R naught by L by K. So आप ये है कि the point is if you are vanishes at infinity as 1 by R to the power n with n greater than 1, this integral converges. This integral converges. And with the phase factor, this delta L becomes finite. On the other hand, if value of L, so for example, if this is proportional to this, the order of magnitude R L is proportional to L by K. for this L by K. So if V naught vanishes at infinity, so 1 by odd power n with n greater than 1. अब हमारे पास क्या है? The thing is that we can have both convergence and divergence of the integral, which means which depends the behavior of u or depends on a large r while the distance or where the radial motion is quasi-classical. If you remember, हमारे पास जो कल scattering formula was there, the scattering formula came out to be the scattering formula came out yesterday to be. So write it here. The scattering formulas they came out to be. 14.1 they came out to be 13.11 and 12. Theta was 1 by 2 y square root of k 12 plus 1 SL minus 1 PL cos theta, or So this is 13.12, or this was the scattering cross section which came out k square sigma is equal to 0 to infinity 2l plus 1 sine square delta. So this is delta L in terms of sine square L. So we are going to see here is such that sine square is equivalent to sine square, or I'll write it here, sine square delta is equivalent to proportional to delta L square. Or the sum of higher order term the series will be of the order L delta L square. So for the well-known, so we have to see whether this series converges or diverges. So if you see sine square L, so the formula is here for theta in terms of this sine square delta L scattering. So if you substitute here and L in terms of sine square delta L is proportional to the square of it. तो जो फॉर्मूला है फॉर्मूला का फॉर्म आ गया L delta L square. Now we are going to see it's in the original formula. Original formula जो हमारे पास है in the form of u. So if it's L R square ये अपना आएगा in that sense. And so the formula will take this form. The formula will take the form of this infinity 0 to infinity L delta L square dl. So replacing this delta L by this kr naught this by kr naught. So delta L is proportional to kr naught. So we are going to substitute here and the integral will take this form infinity u square upon and r naught to dr naught. So यहाँ से basically dr naught आएगा, but since the integral is there, so it will be r naught by 3. So that's r naught by 3. Now the thing is here. So you have a unique relationship of this potential with R naught. So depending upon the choice of R which you have chosen and this U naught, so we'll see how the trajectory will come out to be. And for a particular value, of 1 by r naught, for example, with n greater than 2. So you will see here if n is equal to 2, it's 1 by r square, it's the integral आएगा 1 by r cube, and this will cancel. So that it will have particular, it will give a particular r. But so it means that solution will be only for greater than n greater than 2, which is 3 or 4 or जो or less than 2 on the both sides of the infinities we come to be. And for n greater than 2, this integral converges and total cross section is finite. So on the other hand, if the integral on the other hand, if the integral on the other hand, if the integral will what I should say, if the integral or if the field decreases more rapidly than 1 by r square, then total cross section appears infinite. It appears infinite in that sense. So in this sense, we can say that classical mechanics, so we can have a relation of how we relate classical mechanics. Field vanishes at or goes to infinity. A particle passing at any finite impact parameter, however large, always under. So in the sense, classical mechanics में अगर we have हमारे पास particle होता है, यहाँ से कोई आता है, so we have something called impact parameter. So impact parameter is, for example, undergoes impact in classical mechanics. Impact parameter undergoes some deviation. So when compared to the indeterminacy of the motion. But here, when you take quantum mechanics into consideration, what I should say is that in quantum mechanics, we can speak of scattering through a certain angle only. So here we come angle only. If angle is large compared with indeterminacy in the direction of motion of a particle. So the impact parameter known is delta O, and it's in this sense impact parameter data. So indeterminacy is proportional to this. So you can see from this, you can see जो हमारे पास impact parameter है, how we can see the same thing because there is always some angle theta can be seen how we define things in the classical sense. But in the quantum mechanical sense, the role of impact parameter is constrained if the angle is only is a large angle, if angle is large compared with the indeterminacy, because classically जो trajectory है it's known, quantum mechanically the trajectory depends upon within the parameters of position momentum variables. We cannot make the position of a particle precision. We cannot it cannot be indeterminate, cannot be determined in the exact sense. So in that sense जो वहाँ से infinite से कोई particle आ रहा है, it's going to have a collision with something. The way we define impact parameter in classical sense, it's conceived from here. And constraints are dependent upon how we arrive at for n greater than 0. We convert for diverse depends. How we can take the value of the potential vis-a-vis. वो potential कैसे 1 by r square है, 1 by r cube है, r n है, whatever that is. And in certain cases, in cases which we have defined there, so we have defined diverges for and n less than equal to 5. Thus, scattering amplitude becomes infinite for theta is equal to 0. So finally, we can consider, if we consider delta L, which is the phase which we started this all delta L. Delta L, for example, basically U is proportional to 1 by r over n, and n can be less than or equal to 1. So हमारे पास जो ये फॉर्मूला थी sigma square cos x, it depends upon the sine square delta L. तो वहाँ पर we use this expression in the formula once we square up this is proportional to this thing, and we can use these two formulas or this understanding of sine delta and its dependence upon and the role of theta. Here SL is a phase vector. So this is, if you remember in the previous class, how we defined SL, difference of the phase between these two states, we define SL. So in the same sense, where we use this thing, these things, and taking total scattering amplitude for theta is equal to 0 will be infinite. And problem of calculating f of theta for theta not equal to 0. So we'll notice the formula that हमारे पास है from the, so you can have f of theta is this twice over k 2l plus 1 pl is a Legendre polynomial cos of theta e to the iota twice delta L. Delta L is the phase. Delta L is this phase. Yes. It can also be this. अब ये we can multiply both sides of this f star. अगर इसको multiply by f star, then it will be multiplied with for iota twice at delta L in my side. Side at f star, which is इसका जो आएगा amplitude, it will be theta square. So it will come out to be the same thing. But for if delta L and delta, they are two different phases, so we can have this formula can have this form. हमारे पास इसका form आएगा ऐसे 12 plus 1. PL is the Legendre polynomial which has been used here in the Hausdorff solution. So it can come out to be twice iota delta 1 minus delta 2. So this is the way we can calculate the scattering amplitude of the thing we are interested in. So that's it. So what we have seen today is basically we have tried to see the scattering formula for a quantum mechanical understanding, from quantum mechanical understanding. So जो हमारे पास incoming collision होता है, once we study classical mechanics में, once we study orbits and once we study closed orbits. If you go to Landau Lifshitz first volume classical mechanics, you can see the expressions out there. So in the same sense, we can go collisions. A particle coming from infinity, it's going to strike something, just like it's going to collide with something. So what are the scattering, cross section, impact parameter, and angle theta? In classical mechanics, we arrive at something. So using the same expressions, we have a certain bound where how we can define things in quantum mechanics, where we saw a peculiar combination of mu and r will define how can the integral will converge or diverge. And further, there were constraints on how we arrive at notions of impact parameter. Within this, within the limits of how we define things, delta H, delta P. And further, at the end, we saw how the phase factor, the scattering cross section, element of delta L. So if we change this phase, delta L, which was basically previously seen from SL, so if we change the phase, the modified formula can come out to be this for the scattering cross section. If the phases are same, delta, so the formula will come back. It will be this. So if the phases may be different, so we can have this formula. So we will stop here.